All right, diving in today, folks. We're looking at gravity die casting
Yeah.
and how it's used to make, really strong and precise aluminum parts.
Hmm.
So whether you're, a designer, an engineer, or just kind of curious about how things are made,
Right.
we're going to unpack this process and answer, some of the common questions that come up.
For sure.
So really the goal here is to just get you the need-to-know info about gravity die casting, make it clear, make it engaging.
Absolutely.
And I guess the first question a lot of folks have is like, how is this
Yeah.
different from other ways of casting aluminum?
Yeah, exactly. And I think, the first thing that comes up is how does it compare to like high pressure die casting?
Okay, so with high pressure die casting, it's all about, really forcing that molten aluminum into the mold, right?
Yeah.
But with gravity casting, we're letting, gravity do the work. It's a much
Right.
slower fill. So you can imagine like pouring honey versus like squirting it out of a bottle or something.
Yeah.
That's a good analogy.
It's a gentler process,
Yeah.
and that actually has a huge impact on the final part.
Yeah.
You end up with denser, stronger parts, and that's because there are fewer of those little air pockets trapped inside,
Right.
which is really important if the part's going to be under a lot of stress
Mm.
or if it needs to be heat treated later on.
Exactly. Yeah. And high pressure die casting, it's all about speed.
Right.
You can make really thin, really intricate parts that way, but you run the risk of trapping air inside,
Yeah.
which can compromise the strength in the end.
Makes sense.
Yeah. So if you need a part that's really got to hold up structurally,
Mm.
gravity casting is the way to go because it's that slower, more controlled approach.
Now, some people might be wondering, like, why not just use sand casting?
Right.
It seems like that would be, a simpler, more straightforward option.
Yeah, sand casting definitely has its place, especially if you're doing like really big parts or you only need to make one of something.
Right. Or cost is a major concern.
Yeah. But with gravity casting, you get a much smoother surface finish right out of the mold,
Mm.
and the accuracy is way better.
Exactly. Yeah. Much tighter tolerances.
So when you're talking about things like, brackets for cars or
Hmm?
industrial components where everything has to fit together really precisely,
Right. Right.
gravity casting is often the best choice.
Yeah. It makes sense. And of course, a big part of how strong these parts are is going to come down to which aluminum alloy you choose.
Oh, absolutely.
There are a few that are really popular for gravity die casting.
Like A356, right? That seems to be like the go-to.
It's a workhorse.
Yeah.
A356, it's strong, it's resistant to corrosion. You can
Yeah.
machine it, weld it. Very versatile.
Yeah, and then there's A319, which I think I've seen used a lot in engine parts.
Yeah, you'll see that a lot in the automotive industry.
Right, right. And then A413, which I guess is really good if you've got like a really complex shape you're trying to cast.
Yeah, it flows really well into those intricate molds.
Mm-hmm.
And then there's Alcy 7M Gray,
Oh, yeah, I've heard of that one.
which is a kind of a specialized alloy.
Right.
You'll see it in like marine applications and things like that.
Yeah, anything that's going to be exposed to like harsh environments.
Exactly. It's very durable.
So it's really interesting how, the type of aluminum you pick
Right.
really dictates what the final part is going to be able to do.
It does, yeah. It really dictates the properties of the part.
So you've been saying how strong these gravity cast parts are,
Yeah.
but, are they really that strong?
Oh, absolutely.
Okay.
I mean, think about it.
Yeah.
Because the metal is flowing into the mold slowly and in a really controlled way.
Hmm.
You just don't get those air pockets
Right,
that you might get with other casting methods.
right, right.
So the result is a part that's very dense, very durable,
Okay.
like we were talking about earlier, suspension components in cars,
Mm-hmm.
parts for hydraulic systems, those kinds of things.
Yeah, stuff that really needs to hold up.
Exactly. Yeah, they need to be tough, and gravity casting delivers that.
Now, what about complex shapes?
Right.
Can you make really intricate parts with gravity casting?
It's really good for medium complexity, I'd say.
Okay.
So you're not going to be making like super intricate jewelry or anything like that.
Right, right.
But you can definitely achieve a good level of detail.
Okay.
And it's important to think about wall thickness, too.
Yeah.
Generally, with gravity casting, you're looking at wall thicknesses of like 3 to 6 millimeters.
Okay.
You can go a little thinner, maybe down to 2.5 millimeters in some cases.
Mm-hmm.
But if you need something really thin, you might need to consider a different process.
Right. So it's good for like, medium-sized parts, medium complexity.
Yeah, and it's capable of handling pretty large items, too.
Okay.
Like I said, engine housings, things like that.
Okay.
So there's a good range of sizes it can handle.
But what about precision? Like,
Right.
how accurate are these parts?
Well, with gravity casting, you're typically looking at tolerances of, plus or minus zero.3 to zero.5 millimeters.
Okay, so that's pretty good.
Yeah, it's actually quite a bit more accurate than sand casting.
Oh, okay.
So you get a good level of precision right out of the mold.
Makes sense.
And then, of course, if you need even tighter tolerances, you can always machine the parts afterwards.
Right, so you can always kind of dial it in even further.
Exactly. Yeah. CNC machining can really fine-tune things.
So we've talked about the strength, the complexity, but what about the aesthetics?
Right. The look of the part.
Yeah, like what's the surface finish like on a gravity cast part?
So the surface finish you get with gravity casting is, it's pretty good.
Okay.
It's relatively smooth. You're looking at a range of about 3.2 to 6.3 microns.
Okay.
So it's not going to be like a mirror finish or anything.
Right.
But it's definitely smooth enough for a lot of applications.
Okay. And it's, probably good enough for a lot of internal parts where the finish doesn't really matter as much.
Yeah, exactly. Internal parts, things like that.
Right. But if it's something that's going to be, visible,
Right.
you can always do some finishing work on it.
Yeah, you can polish it, coat it, anodize it.
Right. Right.
All the usual finishing processes.
Right. So let's talk about the bigger picture here.
Okay.
Mold life
Right.
and cost, because those are always big factors in manufacturing.
They are, yeah. I mean, one of the great things about gravity die casting is that the molds last a really long time.
Okay.
You can get like 100,000 cycles out of a mold.
Wow. That's a lot.
Yeah, it's very durable.
So that means you can make a ton of parts before you have to, replace the mold.
Exactly.
So how does it compare to like sand casting in terms of cost?
So the initial cost of the mold for gravity casting is going to be higher than for sand casting. Yeah. But the cost per part goes way down as you make more and more parts.
Right, because you're using the same mold over and over again.
Exactly. So it really makes sense if you're doing larger production runs.
Yeah, if you're making thousands or tens of thousands of parts.
Yeah, then the cost per part becomes very competitive.
Okay, and after you've got the part,
Right.
can you do any additional work on it?
Yeah, I mean, a lot of times you need to machine a part after it's been cast
All right.
to get the final dimensions and features.
Okay.
And gravity cast parts are, they machine really well.
Okay.
So that's a big plus.
And what about welding?
Yeah, you can weld gravity cast parts.
Okay.
Depends a bit on the alloy,
Right.
but A356, for example, that one's great.
Yeah.
It machines well, it welds well.
So it's very workable.
Yeah, it's very adaptable.
Okay, so who's using this process?
Right.
Like what industries rely on gravity die casting?
You see it in a lot of industries where they need parts that are strong
Yeah.
and dimensionally stable.
Okay.
So the automotive industry is a big one. Marine equipment, industrial machinery.
Right.
You also see it in medical devices and even in some renewable energy technologies.
Interesting.
So it's a really versatile process, and it's used in a lot of different places.
So gravity die casting, it's a really interesting process. It seems like it offers this really great mix of strength, precision, reliability.
That's
and, it's used to make all these important parts across all these different industries.
It is, yeah. It's a robust solution for making quality aluminum components.
Definitely something worth knowing about.
For sure, yeah. It's a great process to understand.
And it makes you wonder, with all those benefits, that balance of cost, precision, strength,
right?
Where else could we be using gravity die casting? Maybe in ways that we haven't even thought of yet.
Exactly, yeah. I mean, there could be applications out there that we haven't even considered.
For making, everyday objects even.
Yeah, potentially.
Really interesting to think about.
It is, yeah. It makes you think outside the box a little bit.
Absolutely.
Yeah, very cool.
All right, well, that's gravity die casting.
Yeah.
Thanks for rounding in.
Thanks for having me.
We'll catch you next time on The Deep Dive.